Let's take a look at this problem. Let's see what we can do with this radical equation. This is going to be a lengthy problem because we have two radical expressions. So it's actually going to take us two separate raising to a power in order to eliminate both of those radical expressions. One of them is already isolated. That's where we need to start. When you have a radical equation with more than one radical expression, isolate one of them on one side of the equation. And then we'll raise to the appropriate power, which in this case would be squaring, because that will undo the square root. The square of the square root of 3x plus 1 is just going to give us 3x plus 1. But now here's where the fun begins. We have to square this binomial. See, this is a binomial. There's one term, there's the other term. We're squaring the binomial. That means you multiply it times itself. If you're multiplying binomials, you must use the FOIL method. The f of FOIL would be 3 times 3. That's going to give me 9. The O of FOIL would be 3 times plus the square root of x minus 9, which is going to be plus 3 times the square root of x minus 4. I think I said x minus 9. It's x minus 4. The I of FOIL is plus the square root of x minus 4 times 3. So that's going to give us another plus 3 times the square root of x minus 4. And the L of FOIL, that would be plus times plus, which is plus the square root of 4 times the square root of 4. You're squaring the square root of 4. When you square a square root, you just get the radicand. That's going to give us x minus 4. The L of FOIL was the square root of 4 times the square root of 4. We were squaring the square root of 4. You square the square root of 4, you just get x minus 4. Now, there's some like terms we can combine here on the right side. 9 minus 4 would give us 5. We've got an x term, so we'd have x plus 5 plus, I have 3 square roots of x minus 4. I have 3 more, so that's plus 6 times the square root of x minus 4. I can't multiply this constant times the quantity that's under the radical. You can only multiply when both quantities are under the same radical. So it has to stay out in front as almost like a coefficient to that factor, we could say. Well, we still have a radical expression, so we need to isolate it. So let's get rid of these terms, the x and the 5 term here on the right side, and that will isolate the radical expression for us. So I will subtract x from both sides. I'll subtract 5 from both sides. That would give me 2x minus 4 equals 6 times the square root of x minus 4. Subtracting x from 3x gives me 2x. Subtracting 5 from 1 gives me minus 4. Now, one thing I notice, the terms that are here are all divisible by 2. So let's make life a little easier for ourselves by dividing both sides of the equation by 2. That would give us x minus 2 equals 3 times the square root of x minus 4. I just divide the 2 into the 6. I'm multiplying there. When I'm multiplying there, I just divide that into one of the factors. Now, to get rid of that radical expression, I will square both sides of the equation again. So let's see if we can handle that. So again, that's going to be what? Squaring the binomial. So that's x minus 2 times x minus 2. The square of this radical expression, don't forget to square the constant here. You have to square both factors when you square a product. So that's 3 squared, which would be 9, times the square of the square root of x minus 4 is just going to be x minus 4. So x minus 2 times x minus 2, that's going to give us x squared. Minus 2x more is minus 4x. minus 2 times minus 2 is plus 4, equals 9x minus 36, right? 9 times 4 is 36. Now I have finally, after getting rid of both of the radical expressions, I have a nice quadratic equation I can try to solve. So let's put it in standard form. So that'll be x squared minus 13x plus 40 equals 0. I'll subtract 9x from both sides, so minus 4x minus 9x more gave me the minus 13x. I'll add 36 to both sides. 36 added to 4 gives me 40. And this is another trinomial that I'd give a quick look at to see if it's factorable. Again, if the coefficient of the squared term is 1, take a moment to see if that trinomial is factorable. To get a plus 40 is either a minus times a minus or a plus times a plus. Since that's a minus sign, the binomials need to both be subtractions. And I think if I take a 5 and an 8, minus 5 times minus 8 makes plus 40. And this is minus 8x minus 5x is minus 13x. So yes, that was a factorable trinomial. And my two solutions are x equals 5, x equals 8. So we've now found the solutions to this radical equation. But remember, when you find solutions to a radical equation, you need to check your solutions. So let's check them quickly, see what happens. Let's put in 5 and try. 3 times 5 is 15. 15 plus 1 is 16. Square root of 16 is 4. 5 minus 4 is 1. Square root of 1 is 1. So 5 works. Gives me 4 on both sides of the equation. Let's try 8. 3 times 8 is 24. Plus 1 is 25. Square root of 25 would be 5. 8 minus 4 is 4. Square root of 4 is 2. 8 also works. Gives me 5 on both sides of the equation. So there's our solution to this relatively complex radical equation.